Hello, everyone. Thank you for joining us for another VES-Artex Academy webinar. Today, we're talking about ventilation in depth baffles with Dr. Mario Mondaca. And I would like to just let everybody know that you're able to ask questions through the question and answer section at the bottom of your screen, or you can do so through the chat. We'll be answering questions at the end of the presentation. And we're also going to be running a short little poll that you can let us know how we've done today. So Mario, I'm going to turn it over to you. Thank you very much for joining us.
Okay, thank you for the introduction. Like you said, my name is Dr. Mario Mondaca. I'm an engineering specialist at ARTEX Barn Solutions. It's not working. There we go. I have a biosystems engineering, bachelor's of engineering degree, focused really on environmental engineering. That's where my engineering and training is for. Then I did an agricultural and biosystems engineering master's degree, focused on hydrology, fluid dynamics applied to dairy. Particularly, we did a cow cooling study on cooling mattresses. And then at the University of Wisconsin, I got a PhD in biosystems engineering, focus on further applying those, the computational fluid dynamics and my expertise for dairy operations, particularly ventilation. That's where I met Dr. Ken Norland and Dr. Nigel Cook. We worked together to evaluate some of Dr. Norland's ventilation ideas, as well as some of the ventilation ideas and modeling of my own. And that led to a postdoctorate study at the Dairyland Initiative, where I developed a ventilation assessment methodology for dairy operations. You can see me and Dr. Banos working out one of those ventilation systems using the methodology that I developed, and really formalize the ventilation recommendations, because before that, we didn't really have a formal definition. We had a bunch of different extension publications, some academic publications, and industry recommendations, but no one had really sort of centralized all of that. Since then, I've been working for Legacy Artex as their engineering specialist. And since we merged to be now VES-Artex, I continue that as a consultant to evaluate and do sales support in ventilation systems. So what do I do as an engineering specialist? I really focus on the heat and mass transfer applications, typically ventilation, but sometimes cooling for dairy systems. And a lot of it is sales support. So a customer will have a question, or they'll have a barn design, and I'll take that design and have something that we're testing, be it the fan angle, the type of fan, the fan location, how that's affecting the cows, etc. And for all future images showing computational fluid dynamic results, which are these colorful images with blue and red. Blue means the air is very slow, and red means the air is very fast. And it transitions from there, from blue to green to yellow, orange, and red. So we do a lot of models of the customer barns. We model some of their new ideas and some of our new ideas. And we've recently started getting involved in some product development and testing for some of the VES-Artex products. I've also been working on experimental design and modeling. This really lets us test some ideas from the CFD model, which you see on the left, and that's purely theoretical, and slowly transition it into something real and an experiment where we're actually evaluating how that airspeed is going to affecting what would be, in this case, a head-to-head platform. So I'm very excited to be part of all of this, and that's sort of where I fit into the organization at the moment. But let's talk about what we will be reviewing today. First, I want to address the basic ventilation concepts. We are familiar with dairy ventilation, but I want to sort of standardize how I'm defining some of these terms. We're going to look at the four main types of adult cow ventilation, see where it all started with low-profile cross-ventilated barns, how HARNER and Smith started with the idea and how it's grown into current applications, particularly with baffles. Then we'll get a little more in depth, more into the academic research of baffles. And finally, we'll end with what I call unintentional baffles, or things that we're installing in the barn, not as baffles, but very much act as baffles towards the airflow. So ventilation is really just some system that it's changing air to accomplish three main functions. You need to provide enough fresh air to maintain adequate levels of temperature, humidity, and air quality. And those levels can be anywhere for OSHA standards in case of workers. It can be based on industry recommendations or extensions for cows. And you need to find a balance between all of those. In summertime, the ventilation system, or coupled with a cooling system, should also increase the airspeed for the cooling to avoid heat stress. And during the winter, you want to avoid fast airspeeds to prevent drafts. And then regardless of what system you end up installing, it should adequately meet year-round requirements. So you need some way to transition between the seasons. This, of course, is affected by regional differences. A ventilation system in Florida will be very different from a ventilation system in Wisconsin because of the temperature and seasonal changes that they would experience. And then we'll talk and define what I mean when I say tunnel versus cross ventilation systems. So this is what I consider to be the ideal ventilation design. This comes from the ASAB standards for ventilation, where you're really controlling for those three components of air quality, moisture, and temperature. But when you control for those changes with the year, at the beginning, when it's very cold, you are mostly controlling for air quality. You want to get fresh air to your cows as low as possible. As the temperature increases, you start to get into some moisture issues. So you need a faster air change to ensure you're not building too much moisture in the barn. And then in the summer, when the temperature is really high, really the ventilation system is controlling the temperature in the barn to keep the difference between the inside and the outside as low as possible. And then at some point we reach the practical maximum ventilation rate. And as many of you may know, that's when you run out of sidewall to put fans. So there is a limit to how fast you can go. And we'll talk a little bit about that relationship, particularly with baffles. So this is what I consider the 4 types of ventilation systems in dairy operations. There are, of course, variations and some outliers that do not fit these definitions, but I would consider this the 4 systems that will account for the majority of ventilation systems and barns, not including open lots in freestyle facilities. I'm not gonna get too in depth. I just want it here for reference so that when you're going through this again, it'll be there for you. But in general, natural uses the natural wind currents with sidewall curtains. Hybrid combines elements of natural and elements of mechanical, typically using the tunnel ventilation, which has a lower ridge, and fans on the end wall, versus cross ventilation, which has fans on the side going across the barn. And when I say tunnel, and this is what we've come up as a definition that fits most of the time. And it really is. A tunnel barn is a barn that drives the airflow parallel to the feed lane. So you see how it would be affecting the cows. The air is flowing. As they're eating, it's hitting them on the side. Cross ventilation is when the airflow is flowing perpendicular to the feed lane. So the cows are eating on the feed lane, the air is blowing across them like so. Oh, excuse me. I want to address this. I'm not gonna go too in depth into the baffles in tunnels. I just wanna quickly address it here, and maybe at the end, if there's times we can discuss it, but I do not recommend baffles in tunnel barns because the effect of baffle is very localized and you end up having too many baffles and it creates a lot of static pressure. This is an example of a facility that I visited that has tunnel ventilation, and they installed circulation fans because the baffles that they put weren't enough. So in general, I wouldn't recommend it. There might be cases where it's the only option, but other than that, there hasn't been any research showing that it's an adequate solution, though we are looking, or I've seen some publications looking into different ways to install baffles in tunnels, and those have some merit, but there hasn't been any conclusive results to give those recommendations yet. So cross-ventilated barns started and typically known or originally known as low-profile cross-ventilated barns. In some regions, you still hear them use that terminology. The MCC Dairy Group in South Dakota, in collaboration with Drs. Smith and Dr. HARNER, started this design idea and set up the first LPCV buildings in 2005. The original design called for an 8-row barn with tail-to-tail, but as you know, some of the current cross-ventilated barns have scaled up to anywhere from up to 8 to 24 rows, and they're getting bigger every time. And since then, a cross-ventilated barn has sort of become the standard for a really large facility because there's some land use savings. When you have too many cows in a barn, particularly in tunnel, there's a certain length limit that once you reach it, air quality becomes a pretty big concern. So that's when producers start transitioning to a cross-ventilated barn because you can fit more cows per unit of square area than you would in a tunnel design because you have to split them into multiple barns. And according to HARNER and Smith in their publication of the results for 3 years of research on the low-profile cross-ventilated barns, the main advantages of this system are a lower roof line, a smaller building footprint, as we discussed, shorter walking distance to and from the parlor because you don't need to have the barn separated. It gives you full control of the lighting and full control of the environment, which is somewhat true. These advantages are really clear in the summer, but they also found that the biggest challenge with these facilities is managing during the winter. This is their original cross-ventilated barn or LPCV barn design. You can see the 4 baffles. It's a tail-to-tail 8-row barn. And I had the good luck to visit and do a risk assessment on one of these facilities. As I mentioned, this is a tail-to-tail 8-row cross-ventilated barn. It designed originally in 2006, following the HARNER and Smith design almost to a T. And we found that it works really well, except for a critical flaw in baffle position. Here's the data that I collected. And you can see that in the rows towards the middle of the barn, we see these red spots meaning that they don't meet what we would recommend as the minimum cooling airspeed. Ideally, we want to have at least 1 meter per second or 200 feet per minute at a minimum. And those stalls were not getting that, even though we had really high ventilation rates. So what is happening with these facilities? If we look at the side view and we look at what the typical flow profiles would be and the effects the baffles are having, typical inlets will be designed to provide 500 to 1,000 feet per minute. So you'll get good inlet speeds, good air speeds close in the stalls, close to your inlets. So we're getting good airspeed there because of the inlet design. Then we go to the next set of stalls and we're getting good airspeed there because we have a baffle right here that's providing those cooling airspeeds. Then we reach this area in the middle where we have the biggest barn volume because it's right at the ridge, and there's nothing there to improve the airspeed. There's no fans, there's no baffles. So the airspeed there, we found that was slow. And then finally, we end on some stalls that have baffles, improving that airspeed. And by redirecting that air. And really what we saw is there's this symmetric design where the baffle is cooling the feed alley, but not really the resting space. And ideally, we would want the baffle to cool the resting space. So our recommendation to this facility was to add a baffle in the middle. They chose to add a retractable baffle so they can bring it up and down during different seasons of the year. Since then, while the core idea of the cross-ventilated barn by HARNER and Smith has remained the same, a lot of facilities have moved to head-to-head platforms where the cows are facing each other, and they've placed the baffle right in the middle. And that's more or less the standard being used right now. There's been a lot of research on low profile cross-ventilated barns to look at their effect on milk production, look at their effect at air distribution, and look at their effect on cooling. But there's really limited research in baffle design. We don't really know if we were to modify the baffles or change the baffles, we don't really know what that would mean for the flow profiles and for the cows. So let's talk a little bit about baffles. So what are baffles? In plain terms, they're a device used to restrain the flow of a fluid, gas, or loose material, or to deflect in one way or another. In dairy ventilation, when we say baffle, we typically mean something that is deflecting the airflow towards the cows, bringing that air from the ceiling back down to the cows, as it's typically said. There is a relationship to calculate how you would size the baffles. Airflow is equal to the velocity times the area. Since the airflow remains the same, in fluid dynamics, there's something called basically, I don't want to get into terminology. So basically, any amount of air coming into the barn has to exit the barn. So we always have the same amount of airflow, regardless of what the obstructions are in the middle. That allows us to calculate the velocity under the baffle, because we can assume that the airflow will always be the same, regardless of the situation. Originally, HARNER and Smith recommended 8 feet above the floor. Some of their updated publications recommended 7 feet above the floor. But as cross-ventilated barns have scaled up and changed, we now size baffles based on the total airflow to get desired airspeed. The way we do this is that we take the total amount of air from the fans, divide that airflow by the desired airspeed, and then we divide that number by the barn length. And that will give us the average airspeed underneath the baffle opening. Typically, we're seeing designs anywhere between 2 to 3 meters per second. Some go a little bit higher, some go a little bit lower. But what's important to note is that all of these are for summer ventilation. And anytime we add a baffle, we are adding a restriction to the flow. In natural barns, when you want airspeed, you add fans, and that costs you electric power. In cross-ventilated barns, you add a baffle, which doesn't cost you electric power directly. It makes the path more tortuous, more challenging for the air. You're adding pressure that the exhaust fans have to overcome. And by overcoming that pressure, they're operating at a lower efficiency. So they are costing electric power indirectly. However, unlike fans that you're sort of in a linear increase, if I add 2 fans, I increase my cost by the cost of those 2 fans. As you're adding pressure to the barn, the fans have a drop-off curve. If they reach certain pressures, they start to lose efficiency at higher rates. So there is a limit on how much pressure you can put to your barn because sooner or later, the fans are just not going to work properly. And because most of the baffle design is based on summer ventilation, there tends to be a lot of issues in winter. Summer ventilation tends to be at least 10 times higher than winter ventilation, even bigger depending on the design. And behind the baffle, we get something that is this recirculating zone. As the air is being redirected under the cows, it gets really high air speeds. It then shoots out and it creates this dead air or recirculating zone. And in the winter, that can create some pretty serious issues because you can see here, these are some videos that I took during my stay at the Dairyland Initiative where we smoked right behind a baffle to see how long that air would stay there. And it's difficult to quantify because the air is diffusing to the sides, but you can see how long. This is a pretty fast, this barn has pretty fast ventilation rate, so the smoke should be clearing relatively quick, but because it's right behind the baffle, it's being trapped. There's been some ideas on how to address this. Some producers have added openings on top of the baffle to allow some of that air and try to break these recirculating zones. But there's been little success. They changed the zone, but but it's still there. It doesn't really break it up as you would expect. Others have tried using polytubes or inlets in the ceiling, but there hasn't been really any studies that have shown that you can really mitigate this issue completely. And the problem is when you are behind that baffle and the air is trapped, particularly in the winter, cows are constantly generating heat and moisture. As this air is trapped and accumulates moisture and heat, eventually you reach the dew point and you start getting condensation. Or as some of you may have experienced, the famous raining barns that I've heard of them, and it wasn't until I finally got to be in one that I saw how crazy they get. The barn is completely foggy and you have constant dripping coming from the ceiling. So to address this, we've seen producers try some ideas like using plastic as opposed to steel baffles or aluminum baffles. They've also used fabric baffles, which have a higher thermal insulation than steel does, so it helps reduce that effect. And we've also seen retractable baffles. So during the summer, they'll use a pulley system or something to bring the baffles down. And then in the winter, they'll pull them back up to prevent those recirculating zones from forming. Because in the winter, we don't really care about airspeed. We want fresh air and we want to have really good distribution. And then in the summer, you bring those baffles down and you get that airspeed again. So there's been some solutions in the industry, but there hasn't been any significant research to back them up yet. But what research has been done on baffle design? I could find very little, but what I did find focused on three main areas: the baffle location, where it is in the barn, the baffle angle. Typically, you've seen them as straight, but what would happen if we angle the baffle and help that airflow transition properly, and the spacing between baffles and how that affects that recirculating zone. The idea behind this is when we calculate the airspeed under the baffle, we're getting a number, let's say 3 meters per second, but that increase isn't immediate. It actually takes a long time for the air to reach that 3 meters per second. And then it goes beyond that, all the way up to 5 to 6 meters per second. But the average ends up being 3 meters per second. Because of this gradual increase, some industry people as well as academics have said, well, what if I move the baffle so that I can hit the peak of that airspeed onto my cows and maximize cooling? So I'm going to relocate this baffle to preemptively increase that airspeed and maximize the cooling in my barn. This is a graph of airspeeds at the resting space with and without baffles. We can see the blue line without baffles. The air is flowing from the right to the left. Sorry, from the left to the right. And you can see when the baffle hits the airflow, we get that sharp increase in airspeed, and the average is, or in between the middle of that increase is somewhere around 3 meters per second, which is what this barn was designed on. But you could, in theory, get much higher airspeeds because, and unfortunately I couldn't use my tablet, but essentially the baffle is somewhere here. And so your stalls are more or less in this location. So the cows are not getting the fastest effect of that baffle. So the question is, well, what if I shift my baffle back so that it's not right at the stalls, but let's say at the feed lane, so that that airspeed will not hit my stalls right where it's the highest. Or at least that's the idea behind this modification. And we've seen a couple producers try it out. Oop, there we go. Here we have a facility, I believe this is in Wisconsin, that installed baffles both in between the head-to-heads as well as the front-facing feed lane. So we have good airspeed at the beginning because of our inlet design. And then instead of having a baffle right on top of the cow, the idea is I'm going to speed up that air first, get cooling both at the feed lane and at the stalls, and then, so I'm maximizing my cooling here, and then redirect that air down again with the baffle. Unfortunately, we saw low air speeds on the next stall, and then again, it repeats the pattern. I have my feed lane and a baffle. So it seemed to be doing that increase that we're looking for. A similar idea is modifying the angle of the baffle. If I increase the airspeed before, as we did with the location, but having an angle allows me to have a more even or a gradual increase, which reduces turbulence. And the idea here is to prevent some of that air from having that big recirculation zone and try and get the flow as straight as possible through the barn, as well as reducing the pressure the fans are experiencing. So we put an angled baffle to try and increase that airspeed before it hits the cows, and eventually repeat that pattern to get as even distribution as possible. So this is all from a study that we did in 2019, where we evaluated a variety of baffle settings, baffle locations, and baffle angles. However, my conclusion was that while there are pretty significant effects on the airflow patterns, it didn't have a significant effect on the cow level cooling performance. And I want to be very, very specific with that. The conclusion only relates to the amount of heat we were removing from the cow. So what happened was the first cow was getting much better cooling because we increased that airspeed, but then the cows after that were getting less cooling. We basically just shifted the airspeed. That does not mean this isn't necessarily a better design. There wasn't a really big evaluation on the pressure distributions or the recirculating zone. It was focused on the cooling. So in terms of cooling, we didn't see a significant difference when we make these changes, but more research is needed to see whether there is a significant effect on the pressure or on the fan efficiency as we're addressing these baffle designs. The last thing is baffle spacing. The spacing between the baffles, there's been a lot of anecdotal evidence and even some of our own modeling evidence that changing the space between baffles can have a significant effect on the airspeed, the airflow, and even the pressure at the fans. It's also really the only place where we can make significant changes. The baffle angle has some pretty serious building implications. Building a straight baffle right through the middle of the support post is a lot cheaper than building an angled baffle that may get in the way of the machinery and would need a significantly higher investment. But shifting some of the baffle locations, maybe put some on top of the feed lane that typically has some type of support as well, or shifting it in the stalls, particularly if there's a tail-to-tail situation, can give us some changes. We're not entirely sure what those effects are. There hasn't been any academic publications, and these are some of our own evaluations at VES-Artex from our customer barns. But essentially what we're seeing is, in some cases, the air will shoot back up into the ceiling, and in other cases, it doesn't. And what we've noticed is that this happens when the distance between the baffle is a little bit shorter. The key part here is that when we've seen that, at least in modeling results, the pressures that the fans are experiencing are actually lower. So typically we think, or at least from some of the HARNER and Smith publications, what's been reported is that as you add a baffle, you're adding pressure. And it's sort of a linear increase. As you add baffle, you add more pressure. You add another baffle, you added that much more pressure. But some of our modeling results from customer evaluations, we've seen that adding baffles either maintained the pressure at the same or had a very insignificant increase. And we think is because we're avoiding this big jump in the air that has, a lot of turbulence and a lot of losses. So there might be what you would call an optimal baffle distance. Unfortunately, there's no research on this. Fortunately, that's something that I want to evaluate and something that we think has merit evaluating because particularly here in the feed lane, we see some dead spots that are pretty challenging to address in a cross-ventilated barn. So maybe putting a baffle there, typically you wouldn't because you'd be adding pressure. But what if you're not? What if we found a way to rearrange the baffles where it would actually keep a very similar pressure profile? So it's a very new idea. We're still discussing the best way to approach this because there's no research on this. So it's something that was slightly addressed by the academia, and it has been seen quite a bit in anecdotal difference from evaluating consumer designs. Oh, that's nice. And that brings me to sort of where we are leading with this research on baffle design and even other product solutions that we really want to do open-minded research. Things that sound silly or break the current norms are not necessarily bad. Here, this is across an open lot fabric baffled cross-ventilated barn, yes, that I got a chance to visit. When I heard about it, I thought it was crazy. Then I saw it and I thought it was crazy again. But then I collected the data and saw there's really only one spot where the airspeed requirements aren't being met. And the pressures were well within what we would expect. So this is actually a very well-performing ventilation system. They can probably do some maintenance on their baffles, but other than that, it works really well for their application. So I think as we've merged with these two companies together and are merging some of these design ideas, we're starting to come up with these questions of, we've always done baffles and cross-ventilated design in these ways. Well, why is that? And how can we answer those questions? And we have now a new facility to address these research questions. It is located in Chippewa Falls. It's really big, which is really good for this type of research because we can literally fit a small dairy plant in a dairy barn in there. For example, this would be a 48-inch head-to-head platform that would fit in around, you could probably fit 2 or 3 of those in that facility. Here's one of our louver fans, and it's covered by these removable panels, so we could potentially evaluate cross ventilation or tunnel ventilation by removing some of these panels and installing exhaust fans and looking at how these small changes to the design will affect the velocity that the cows are experiencing. So I'm really looking forward to this. We've already started some of this at these evaluations. We did some velocity mapping for one of our products because we have a lot of information of the CFM that the fan is providing, but that doesn't mean anything when you're trying to put it over the cows. We need to know what the cows are experiencing, both with baffles and with fans. So some of these research questions that I brought from baffle angle and baffle location, I think we have the facilities and the expertise to start answering them and really say not just, well, the fans will perform better, but say it will affect the cow by changing the velocity by this much, or it will change the velocity profile at the cow level by this much. So I'm very excited to be part of that. I'm looking forward to this type of research. Maybe in a future webinar, we can answer these questions that I've addressed, but right now they're still just questions. We don't have any research in academia or in industry to really challenge those ideas. And I'd like to finish with what I call the unintentional baffles. We don't typically consider these installations as a baffle. But as we've looked at more analysis of barn ventilation, both by going to facilities and evaluating them, and as I've modeled a lot of these facilities, it has become very clear that these components have a pretty significant effect on the overall flow. Concrete components like stalls, crossover walls, steel components like post, waterers in some cases, plastic waterers, sometimes they install dividers, and the cows themselves are baffles in terms of flow distribution. This is a study that I did on a tunnel ventilated barn. And I mentioned we wouldn't recommend baffles, but most tunnel ventilation barns come with built-in baffles. Crossovers are typically installed with a 4 feet, 5 feet wall that protects the resting space. The idea behind this is you're creating a barrier that prevents cows from either bothering other cows, or it prevents the water. Typically, you'll see waters in these crossovers to splash into the sand, which is really good. It's good for cow behavior and it's good for management. But we found that in tunnel ventilation, at least, they create these dead zones, and it repeats over and over. And it doesn't matter how fast I ventilate. We went all the way up to 120 area changes, which is double what you would see. You can't fix these dead zones by adding fans on the wall. So if you've noticed, some of the more recent tunnel ventilation barn designs have reduced the overall ventilation rate and instead installed fans the way you would see on a naturally ventilated barn. So because of these baffles, which is what they are, now they're redirecting the flow away from the cows, we have to address the design either through installing fans, or I've seen some tunnel barns designs that move the water to the top side of the crossover so that they can reduce that wall. In cross-ventilated barns, we don't have the same effect because of the direction of the flow. Instead, we have issues in the feed bunk. Typically somewhere around 24 inches from the floor to the top of that feed bunk, and then you have the headlots. That's redirecting the air up in a cross-ventilated barn. The first models that I did of cross-ventilation didn't include those concrete components, and they came out with a straight flow, which we knew was incorrect. So once I added that stall geometry and that feed geometry, we noticed that this air is being pushed back up. And I actually was in a call with Sue, one of the sales, who was quoting a barn in a very hot environment that has this issue that, you know, the cows here are going to be eating in essentially dead air. And right now we don't have really a proven way to address that. We saw some designs that move the baffle to the headlot, but that hasn't been standardized or it hasn't been like proven to work and to not have a significant effect on the rest of the airflow. So we're left with this issue, and we don't really have a proper answer, at least academically speaking, because we could always install fans. It's just it costs, and now you have to make an analysis of, well, what kind of issue do we expect from having dead air in this feedlot compared to the cost of adding those fans, and where is the balance between? And it becomes this very challenging problem that we weren't aware when the cross-ventilated barns were first introduced, because we haven't really modeled such small details that actually have a pretty big effect on the overall flow. And even in some solutions, like this is a water throw that it's meant to, it has a shield, which allows you to avoid the crossover wall, as we mentioned before. Here we have a much shorter crossover wall. I think it's only a foot off the ground. But the water throw itself is a baffle because you're blocking the air. And we can see this really big recirculating zone right after the stalls. So that producer had to install fans to alleviate that issue, because really like 30% of his stall bank was getting dead air because of that water throw. So We've seen that time and time again. This is a facility that I visited in Tennessee, I believe, that there is no crossover wall after that water, but because how big and it's basically just a straight wall that water is, both on the modeling results, we're seeing these blue dead zones right after every water that affects the immediate area after the water is typically a resting space where we want the fast moving air to be. And the data that I collected from the facility shows the same thing. At standing height of about 1.5 meters above the cow, the airspeed's great because that water is deflecting the air up. But at the resting height, we're getting 100 feet per minute, well below the recommendations, and that repeats throughout the barn. We have a water, and then the resting speed is low. A water, and the resting speed is low. Water, the resting speed is low. Water, resting speed is low. So all of these quote unquote unintentional baffles we're starting to become more aware that some of these dead zones and some of these dead air comes from what we would consider standard design recommendations, because it's really good to have the water there for, water accessibility, cow, even heat stress and cow flow, but we haven't really addressed how they affect the airflow and how we're going to mitigate that problem. Oh, I must have missed the slide. The last, we mentioned this during my last webinar, but as AMS facilities are becoming more commonplace, they are also baffles. They're a big room of combining plastic, steel, and concrete that are really changing how we see ventilation in adult cow ventilation. They're almost like a design of their own. We have to separate a traditional design and an automatic milking design, because how they separate the airflow by having such a big deflector in the middle of your barn, or multiple of them, and how they combine different ventilation zones into a single one really changes the design. So it's inherent to the design, so we can't remove them, just like these other components. So we need to find new ways to address them. And like I mentioned, I'm very excited that with this new VES-Artex, we're really collecting the tools and the personnel that can make those research questions and start addressing them. So we went through the basic ventilation concepts and what I consider the 4 main ventilation designs. We started with the HARNER and Smith 8-row barn, tail to tail. That had some issues, and we've now scaled that up to 24 rows, 18 rows, and that's brought up even new issues that we're starting to address through baffle angles, baffle position. We changed how we size baffles, and now we're starting to look into the little baffles scattered throughout the barn and how we are going to address that. And in the future, we will start looking into, well, how do the cows affect their airflow? And is there a way to optimize the design based on that? Well, we got to start with the more static components first, the waters, the location of different concrete components and whether those can be changed or addressed. And then eventually move into, well, how do the cows themselves and cow behavior affect ventilation? So that's more or less where, at least in my opinion, where I see the current design of baffles is. They're very good tools to improve airflow in cross-ventilated barns, but there is a cost to them. It comes in pressure, and we're looking into ways to minimize that cost as much as possible so that we can get a system that works well throughout the year and a system that provides that cooling airspeed that the cows need in the summer. Okay, thank you very much for your time and for being part of the webinar, and I'll be happy to answer any questions.
Perfect. Thank you very much, Mario. We had a question. What is a realistic assumption for static pressure increase per baffle in a tunnel or in a cross vent, or is it the same?
That is a question that gets asked a lot because there isn't, it changes with so many things, with the baffle opening, with the cows, with the baffle position. So there isn't, there is a published equation for it, and I can reference it after this webinar. I don't have it handy to make that calculation, but through our modeling, we've seen that that calculation is sometimes wrong, particularly with that baffle spacing idea. We've seen that in some cases, the baffle spacing makes the previous published equation for increase in pressure per baffle completely different. So I'd be wary to give a straight answer because I don't think there is a straight answer right now. That being said, crossbars typically operate between 0.05 to 0.2 inches of water, and that's the whole barn. So whether that's from the cows or from the baffles, we're not sure, but that's a typical range as you see.
Thank you. So someone asked if you would introduce positive pressure to ventilation or along with baffles.
That's an idea that's been tested and discussed by some producers. I haven't personally done any research on that. I would like to. I'm not so sure. It really depends on the facility because polytubes have a limited amount of airflow. Like you have one fan and maybe 300 feet of tube. So that's 300 feet of airflow that one fan maybe gives you, even if it's a really large fan, it'll give you 40,000 CFM, for example. But in those 200 feet of barn, you'll have maybe 16 or 32 exhaust fans. So the ratio of air that you're injecting into the stream, it's like, is very one-sided. So you're fighting a lot of air. But there have been some people that have done inlets or that have done multiple tubes. There just hasn't been any data that I've seen that really validates it. But I haven't seen any data that makes them a complete waste. So it's really currently being addressed, I guess. And I expect some publications will come soon, either by academia or hopefully by myself. But it's an idea that has merit, but there is no information right now to make a solid recommendation.
Another question is, would you recommend the use of curtain baffles to better deal with winter and summer ventilation strategies?
And this might be a biased answer because producers like the things they already bought, but every person that has installed baffles that are retractable seems to like the control. And I say that very carefully because a lot of these producers tend to be on the top producers. So they do a lot of maintenance, they maintain that system, and they make sure everything's clean, etc. So you're adding a moving part to what was before a static system. So you need to do maintenance. And if you don't do that maintenance, sooner or later, that moving part will break. But having that freedom and that allowing to prevent those dead zones has been good. A lot of cross-ventilated barns install just the last few baffles as retractable baffles, where you have the most humid and most hot air, and that really lets essentially that air distribute a little better. So there hasn't been a sort of gold standard on retractable baffles, but the people that in my experience, the people that have installed it have had a positive feedback on them.
Thank you. Another question is, what about using powered baffles, so circulation fans in place of standard baffles to cover a pen? They're asking if it would allow less exhaust fans and a slower air exchange.
I've seen some designs. I almost mentioned a brand, I'm sorry. I've seen some designs of that. Essentially, instead of baffles, you have fans over the stalls, pushing air towards the cows. There's issues of efficiency, but of course they provide cooling air speeds because they're fans. So I don't have an answer. All the publications from like Midwest Planning Service and some of the extensions say that circulation fans do not provide air exchange. So by those standards, you couldn't replace exhaust fans with circulation fans. I haven't seen a publication actively test this, so we don't really know if that statement is based on experience or on a lot of data, but until that's properly tested, then we tend to assume that a circulation fan is not providing ventilation, it's only providing a localized cooling airspeed, and the exhaust rate should be separated from that. So yes, they can replace a baffle and they can provide fast moving air, but I would not say that they would help you reduce your exhaust fans by providing ventilation.
So the same person asking the question is asking what air exchange is in cross vents. Are they well under 1 minute?
And I apologize, I work on the air exchange per hour. Typically we see 40 to 60, usually 60 air exchange, which would be 1 minute. I haven't seen anything above that. I think the pressures get a little too high.
And what is the best way to ventilate the robot area?
It's a good question. You should watch my old webinar. We don't really know. It changes with the design. It changes with whether depending on the robot layout, whether you have L or toll gate or whatever design that you have, how those buildings inside a building are affecting the resting area and what you would now call the new holding area, which is right in front of the robot, how that is laid out in relation to the ventilation system. It's how you're going to determine if it's where you need to address it. We talked about some of these ideas in the previous webinar, which I think is accessible.
Yes, it's on our YouTube channel.
So we got really in depth in like, well, what if this was a tunnel? What if this was a cross? What if I put fans here? What if I put fans in a different location? So, but the main takeaway is we don't have a good understanding of the impact that we have by, if we ventilate that robot area really well, we may affect the cow flow because the cows find, there's food, water, and candy close to the robot. So if it's also now the coolest area in the facility, we may impact the efficiency of the robot by having cows really like that area. So there's a balance. It's a multidisciplinary problem, and we're not sure where that balance is yet. We don't have any publications addressing effects of ventilation and cooling in cow flow, at least not that I'm aware of. So we don't really know the best way to do it yet. We follow the current standards on adult cow ventilation, which don't fit 100%.
Thank you. So just an aside here, you can access all of our webinars via our YouTube channel, or you can email us at marketing@artexbarn.com and we'll send them to you. The next question is, what is a minimum air exchange for extreme cold weather?
Typical recommendations say most barns use 4 air exchanges per hour for the winter. However, from experience, in extreme cold, we've seen producers go down to 2 air exchanges per hour for very small amount of times, only when needed, because the air really the air quality starts to decrease. So in general, 4 air exchanges per hour, and then producers, as they get more familiar with their facility, they've gone below that, or if they even started doing pulse ventilation, stuff that it's a little too custom to make a standard recommendation. So it really is case by case, but in general, 4 air exchanges per hour is the typical winter recommendation.
What do you think about leaving a small gap at the top of the baffle near the ceiling to prevent the dead zone?
We've seen that actually. We showed a model. I think I have it. Yeah, so it does add airstream up there, but it doesn't really solve the recirculating zone. So the recirculating zone's still there. It changed its shape, and now the very top of the barn has fast moving air, but it didn't really break it up. And then we still have that dead air that accumulates temperature and humidity. But this is a case study. It's one barn in Wisconsin, so Your mileage will vary as to how effective that solution is, but from what I've seen, it doesn't solve the recirculation issue.
With addressing the dead air in the feed lane, as based on the distance from the baffle, the air speed increases, would you put a baffle on the feed lane or the inlet side or on the exhaust fan side of the feed lane?
That one I'm not sure. That one's honestly, it's up for researching. We haven't done a sort of baffle distance and location optimization study. The most obvious seems to be put a baffle on the feed lane, but there's concerns of what happens when all the cows are eating, because as herd animals, they'll all eat at the same time. So now you're restricted most of that headlot, and the top is now restricted by a baffle. So while it sounds like the obvious solution, there might be some cow behavior that makes it not such a great solution while the cows are eating, which is when you want your cooling. So in theory, it makes sense to put the baffle in the feed lane. In practice, I think we're gonna learn that may not be the best, but there's honestly no research on that at the moment that I'm aware of. So it's ongoing, and yeah, sorry.
No worries. So is there an advantage to having baffles closer together? Will it provide a uniform environment and velocity across the full barn?
I'm gonna carefully answer that one. From what we're seeing in models and in some producers, that may be the case, but it hasn't been validated. So that's what we're looking at into with this. This is the same barn by a producer that wanted to test different baffle configurations. And we saw that, yeah, if the baffle is a certain distance, you'll get that even air distributed at the bottom, which helps with the pressure. But this is modeling. Some of our salesmen have told us that that is true, that they've gone and tested it, and this is what happens. Sometimes the air jumps all the way up, and in other cases, when the baffles are closer, it stays well below. And we've seen that as well in some of the analysis and barns that I've evaluated, where you'd think the airspeed would be low, but it's actually fast, even though there's no baffle there, because the air is being kept by that recirculating zone. So things are pointing towards that answer, but we don't have, at least in research terms, we don't have that validated, and we don't have a optimal distance or optimal baffle distance. So I'm sorry I'm being so careful with that one, but I don't want everyone to just start filling their barns with baffles, right? It might as well be a false ceiling at that point. So I really want to stress how this is an effect we've noticed in industry and in modeling, but it's currently not validated.
Thank you very much. So that was our last question. There's been a request for the presentation itself, and you can email us again at marketing@artexbarn.com, and we'll provide that to you. I'd like to invite you to join our next webinar. It's Challenges and Opportunities for Human Resource Management on Dairy Farms. So that's on March 12th with Caitlin Mills from the University of British Columbia. Thank you very much for joining us. If you've asked a question that wasn't answered, we'll make sure that Mario gets it and he can answer you personally. So thank you very much, everyone. I hope you have a great day.